Okay. I hope you can hear from me. And today I'm going to talk about the midterm. What I plan to do is today I give overall, and by the end of the lecture, I hope you have some idea about what I'm approaching to the midterm. One of the important things is the way you're going to answer the midterm, because it's very specific. I want to make sure you understand that. And then from now on, you can actually asking more questions. Before I go into this, I want to tell you that what I'm actually looking for the midterm. So there are some basic principles that I would like you to actually apply those principles we have taught. Specifically is about how do you define a class? How do you actually define a class hierarchy? And how do you actually define the component within an object? And how do you actually define the interaction, means the method, the member function, which is the interface, and how this interface are going to communicate with each other. So those are the basic fundamental I want to make sure you be able to apply, not just learn in the programming way, but you can actually apply to a scenario that's given to you. Is like a Little Red Riding Hood. And now we're going to actually go into a little bit more complicated. The second perspective I really want to test you is about creativity and innovation. I will give you some hint about what I'm actually looking for there. So what is an innovation? Innovation is your thought process to decide how to actually handle a particular situation. So that's the thoughts. But you will be able to realize that thoughts using object-oriented programming. Of course, I'm not going to ask you to write any program. That's why I want to spend today to tell you how you actually express your thought, especially innovative thoughts, in an object-oriented way. Because at the end of the lecture, hopefully you actually will see if you can actually represent that. It's just very mechanical to transform the way I asked you to do in the midterm to a real program. That part is not a hard part. That part, once you understand the inheritance hierarchy has a relationship, you actually know how they should interact. Then it's just you use your programming language, regardless of C++, Java, or Python, or whatever language, that you will be able to translate that into work, okay? And what I said, creative innovation, if you actually come up with something which is, I would say, pretty standard or pretty average expected. I mean, this is actually very subjective. That's instructor has to decide whether that's actually make my job harder, but I will try my best. But if you actually using your thought process, come up with some perspective, is actually quite surprising. So that's why from now until the day we're going to have a midterm, you can actually probe some idea with me or within among yourself to actually see whether that's actually something interesting. And if you have an average or not so innovative, you will actually get a grade maybe around B. But if in order for you to get an A in the midterm exam, you need to actually come up with some innovative perspective, and not just come up with something which from the thought process is really innovative, but you will be able to realize that using the object-oriented paradigm. So that's two parts go together. Okay, so let me actually tell you, I already shared the link that I assume you already watched the video, that we're going to actually look at this as a context. So if you watch a video that this is a decision process, okay, again, it's a decision. And when you make a decision, we will, after I talk about this, you will actually start to recognize what are the options in this scenario, in this decision support process. And what's the class and how the objects should interact with each other. Okay, so in this scenario, let me just first, let's talk a little bit. This is the very famous, the ethic dilemma for autonomous car. In fact, this has been bothering the whole industry, that this has become a barrier for our level 5 autonomous drive to be fully deployable. Right now, if you know somebody is driving a Tesla, and Tesla, I think, is only level 4. And level 5 is something which Google and a few other companies try very hard. Even last weekend, when I drove to San Francisco, I saw a few way more than the car that's actually on the street. I was saying, oh, how far they actually developed that technology. That's some of the innovation will come up from there. I will explain to you what do I mean by that. So essentially, what you want to deal with is that you have 3 choices when the big object that's actually cut loose and starting to rolling, or actually it's like a storm that way coming to your car. And the thing is that the autonomous car usually, well, that's actually, I think, is still a viable option, is of course sacrifice yourself. Just hit it, you die, your passenger die, and the car will actually say you're a hero in this process because computer program decide you sacrifice yourself. I mean, that's actually not very a good marketing strategy. Okay, so it's actually going to hit the right or hit the left, right? The left in this picture, you can see that is a, so which one, I mean, there are 2, right? One is actually the one that's actually not wearing a helmet, and the other one is wearing a helmet. I mean, for those of you who actually watch the video, I typically ask all the students, what do you think? Which one? If you're going to make a decision, which side you're going to hit? The one with helmet, the one without helmet. Which one you should hit if you have to have that?
So from a capitalized standpoint, I would hit a cheaper bike.
You would hit a cheaper bike.
You wouldn't have time to think, oh, look at the cheaper bike.
Well, the AI can decide.
No, AI, I agree with you. AI can decide. Yeah, AI can decide. Okay. So what other thoughts?
But going back to the helmet, I would hit the one with the helmet because obviously it's more protected than the other one.
Okay. So in the future, in Davis, the city of Davis, we deploy this policy.
I never wore.
No student will wear a helmet, right? No student, because if I wear a helmet, I actually, okay. All right, if you think that you're gonna hit that, how about this one? This is actually me against you guys, okay? I'm the generation of people which is expendable, and I'm actually leaving the society very soon after this quarter, right? Or after this academic year. And so, by the way, this might be my last year teaching this subject. So which one? Should we hit the younger one or older one?
None.
But assuming we don't have a choice, you either sacrifice yourself or you hit the older person or younger person. Well, that's actually, I mean, people argue that you should hit the younger guy because he has, what do you call that? Probably the health is actually recovered much better, and the chance he can survive is much higher, except he might lost one leg and one arm or something like that. What?
Medical care will be too expensive for as if he is an old guy.
Yeah, it's
the greatest not that.
I think that's a good idea, right? You can see that this. I mean, even more interesting is that okay. Now we talk about ethics. All right, we talk about this kind of diversity or this is a very controversial topic. I mean, we have a different, color of people in this scenario. Which one, right? I mean, that actually became a really important issue in this generation of AI system when they actually inherently, because they're using machine learning, and the data contains some discrimination against certain feature, and then the decision making is actually implicitly make this kind of biased decision. For example, I mean, the favorite one is this one, the last one. I mean, which one you're going to hit? Ethan Hunt or the other guy?
Ethan Hunt.
No. The reason I brought this is Ethan Hunt is actually carrying a national security mission.
Oh.
If you actually hit Ethan Hunt, another 2 million people will die.
Well,
that's possible, right? The missile with nuclear and biological weapon is going to hit the downtown San Francisco unless we let Ethan Hunt survive, right? I mean, that's possible, right? If your system, your AI system, right, is so smart, they actually realize that they're equal otherwise, but he has a very important mission. I mean, for example, if this one is Felix Wu, I have a mission. You better not hit me because I need to deal with 150 students. I mean, at the end of this quarter, that's okay. You can hit me. But before I turn in the grade, then you better not hit me, right? Because there is 150 students will be affected. So there is a mission perspective over here. So you can see that is it's really interesting that this is a decision-making process that I'm talking about. I will give you more specific about what I'm asking. I'm actually going to ask you something more difficult than I just showed you. Well, it's not necessarily more difficult. What I show you is that you have a one center object, which is the autonomous car. It's trying to make a decision and receiving input. All the question I ask you is, you actually got all the information, and then you decide whether you want to hit this, you want to hit that. So when we say a decision-making is transparent, that means I know which piece of information is actually push the autonomous car to take that particular action. And by the way, that is very important for today's AI system because the hardest problem in today's AI, one of the hardest problems is explainability. Means that I make the decision which sounds okay based on the training data set, but I don't know why. And I don't know why exactly, which feature, what is, this is called explainability. So that's typically today's autonomous drive. They're thinking about, I'm getting all the information. I'm getting information about the health record. I'm getting information who is actually very depressed. Oh, he wants to commit suicide anyway, so I'm going to hit him. Okay, for example, you get this information from a social network, right? You say, well, this guy, he is a supporter of a politician, which I really hate. And I don't think that anybody should vote for that. So you hit him. I mean, what is the reason for you to actually make that action? I made a lot of jokes. Okay, none of those should be considered seriously. I'm just illustrate how bad a system could potentially design. Okay, so the thing is, I really want you to do now. I start to talk about your midterm. What is the same context, but I mainly want you to do this is for autonomous drive, how do you define the class and objects? That's going to illustrate and implement the following challenge I'm going to give you next few slides. How do you define object? And then the second question is very important, is that how will those objects interact with each other? That actually make a difference between what do we call that, the ethic dilemma about left or right into a different problem. The different problem is this, is that I actually want them to talk to each other. So what do I mean by want them to talk to each other? Of course, when you're driving, you cannot talk to the rider of those one, that gentleman without helmet or that gentleman with helmet. You cannot talk to them. There's no time for you to talk. But you can actually talk to the motorcycle. So essentially what we're looking is that defining the process about how car should talk to motorcycle. I mean, in the machine time, that's actually you have time. Before you really have the impact to the car or to the motorcycle and the passenger, that's actually, there is some communication you can actually come up with. I mean, let me give you an example. For example, the motorcycle, I don't know how you call that. There is an escape seat, means that it has a parachute, you can actually shoot. It's a rider or passenger to the side to avoid some impact. Or the motorcycle has some mechanism that actually can protect if I was selected. So now it's easier to say, okay, you have a two motorcycle, one with that capability to save 100% of the passenger and the rider, and the other one, it doesn't. And then you can actually be able to communicate to know that and decide which one. So that is a decision process. So you have a question? Yeah. So the thing is, talk about car talking to motorcycle. And now we're saying that, okay, I just give you some example, but what information you need to communicate, you need to decide. You need to decide this. That's why your creativity come up. What do you think information can be exchanged between the car and the motorcycle in about 1 second, and such that you can actually, based on that interaction, for the car to make a decision? Okay, that's the. So requirement number one, you're going to define a bunch of class. The class will have a class hierarchy, which is a relationship. And for example, I could have a parent class called autonomous vehicle, and the child class has an autonomous car and autonomous motorcycle or whatever you want to define. Okay, so you have to define the class hierarchy so we know how they're related to each other. The second requirement, of course, is what we call the containment hierarchy, or actually the content of the object. So over here, okay, by the way, how do you actually express in the exam? I'm expecting you to draw, for requirement number one, I'm expecting you to draw a diagram looks like this. Okay, I want to standardize such that I won't misinterpret that how you express the class hierarchy or requirement number one for the decision making, okay, number one. And the second one is actually the content of the object. Then I'm expecting you to write some form of pseudocode similar to this one. I mean, you can use C++ syntax or something which you miss a semicolon, I'm okay with that. Okay, and if you miss the inheritance, for example, you didn't say colon, public, or whatever, auto V, that's okay. Because what? I have inheritance hierarchy. I know the relationship with a class, okay? So this is just a pseudocode to represent the content about the object. So the content of the object contains two parts. One part is the content. For example, this is the motorcycle. It has a rider, which is a person object. And it has a passenger, which is also a person object. And then it might have a like hybrid robot component. That's actually, you can decide whether you want to have that. Because think about that, today's autonomous drive, they don't have this. But in this scenario, I might actually want to create a robot. And the purpose of this robot is when I'm dealing with this kind of scenario, it will actually orientate itself to protect me the best it can. Because you probably know that the motorcycle today, you have fun, you really ride the motorcycle, but the protection is really weak. Whenever something happens, the the damage to the person is actually really, really serious. Okay, so well, you might actually want to create a one or more robots to actually, for this purpose, at this time it can activate to actually try to reduce that kind of damage. That's your choice. And then you have the second section is about method and interface. And the method and the interface are actually basically allow this object to communicate with the other object. So you have to define that. And the third one is how okay, so just before I move on, that this is the way to represent. Okay, roughly this is the way to represent. You should clearly say which one is a class and which one is the component. So this is just represent has a relationship. For each of the requirements, there are numerous ways that you can represent your idea. For midterm exam, I don't want you to use other way. Just use the way I basically describe here. So then, for me as a grader, I will be able to understand what you try to say in the diagram, in the design. And the third one is communication. It's about communication. So the way to describe communication is usually I create a few bars. Each of the bar represent one object. And in the chronological order is from the top to the bottom. So for example, the first message, you don't even think about, you can think about it's a member function call, but you can also think about it's a message. It's a message, it's a function call, for example, I just give an example because you have to define your own. For example, just alert. I'm actually going to send a message to this motorcycle to the left saying that, hey, I might need to hit you in about 2 seconds. I'm actually under the situation, as you probably can see as well. And now we're going to exchange about how you could be the one I'm going to hit you. So you can see that the decision is not made alone by the car in this scenario, that you're going to actually communicate with a few other objects that in this scenario, they might be impacted in an autonomous way. And the thing is that you actually have your autonomous motorcycle already programmed to be able to respond to certain things. For example, it says one of the very noble writers saying that, okay, I have certain robots that's actually going to protect me. Thank you for telling me this. My motorcycle is going to do. It's going to turn the other direction to reduce the impact, for example. And this motorcycle might respond with a different thing, saying that, hey, unfortunately, I forgot to wear my helmet today. So you better not hit me because I have whatever brain surgery last week. If you hit me, it's really going to kill me. For example, those kinds of information got exchanged. And then after a few rounds of communication, that the system, the car is going to issue, say, hey, I'm going to hit you. I'm sorry. That prepare for whatever. So you can see that right now is still similar to what we had before, but it's very transparent. You know the reason, you basically explore every possibility to reduce the damage to the people. So that's kind of one question. Remember, I said I'm going to ask you 2 questions. That's the first question. Okay, the second question I want you to engage. I'm actually going back to this scenario. I will call it, the second question is similar to that, but I actually call it predictive risk avoidance. So essentially, I know if the motorcycle is indeed going to that direction, then essentially, I actually going to make a hard decision, either hitting left or hitting right. But if I actually realize somehow I can communicate, somehow I actually, for example, this box, it could be an object there as well. I realize that object, I actually analyze that object has a risk of turning loose against this car. Then essentially I will try to calculate. It's like a multiverse, what Dr. Strange is doing. He basically calculates every single possibility and try to see which one is actually the one that's going to happen best for everybody. Well, not necessarily for everybody in that case, but you can actually do this kind of calculation. And among the three vehicles, that you can actually find a way such that this will never happen in the first place. Because you actually predict and seeing that this car actually saw this, saying that, wait a minute, if both of you actually come here, I'm going to hit one of you. So at most, one of you can come here. The other guy, you better back off a little bit to give me a space that I can turn into. So that is another way to look at this problem. It's still object, inter-object communication in the autonomous drive. It's such that you always create space for this kind of things to happen. Okay, so there are two scenarios that, the first scenario, I only tell you the requirement is the car needs to make a decision. By the way, you can actually write a very average answer is that whenever this happens, I don't actually even bother to send this is one answer. By the way, this will give you a C or D, just to let you know. You can say, okay, when I have this, I just flip a random coin. I flip a random number. If it says greater than 0.5, I hit my left. Lower than 0.5, I hit my left. Okay, that is a decision making, right? Without any communication, I actually make a decision. But at least I know why you make the decision, you flip a coin. But I want you to be thinking about what you think should be communicated in this process. Don't communicate too much, okay? Just think about something that's actually very unusual, very interesting. You can communicate, and then how to implement that in this diagram to represent. The ultimate decision is actually at the end, is going to make a decision. And the thing is that this diagram with the class hierarchy and what we call the hazard or containment hierarchy will actually give you a very transparent picture to understand how the decision is made. So this will be something which is for you to understand. So that's the first question for your midterm. The second question for your midterm is that, well, how will you communicate and such that you can actually avoid the situation? What kind of information you need to communicate? And so the idea is what information is communicated. Like you don't need to communicate your health or blood pressure or your Ethan Hunt or not. Those are irrelevant. The thing is that what should you communicate? And such that you won't actually get into that situation in the first place. And that one, you probably don't have too much innovation because the decision is based on the situation and how do you actually communicate enough information to not get your autonomous car into that. Okay, so those are the two questions I'm going to ask you. By the way, before the exam, you can actually talk about that. You can talk about yourself. You can actually talk to me. I will actually provide an exact writing only during the midterm exam, but it will be fairly similar to what I just said in this recorded video. Okay. And from now, before the beginning of the November 4th, you feel free to ask any question for clarification, for any help you want. But during that exam, what's going to happen is that I'm going to pass you a few paper with some of them. Actually, I will have this kind of bar, so you can actually draw that easier. And then you basically doing handwriting on that paper. Don't use computer or anything. It's just because some of us, we don't have a computer, the kind of device to do this easier. So it's just to be fair, I want everybody just handwritten. So that's why don't try to write a lot, but just using this to describe how the decision is being made. Okay. Is there any question? Is that understand what's happening in the midterm? Okay. All right. So yeah, yes, please. Yeah, question one is about how will the autonomous car in the middle after the interaction with other objects is going to make a decision. How will that decision be made? Meaning that what message is going to be communicated with other objects, meaning other autonomous car, and also what information need to pass. For example, if you actually come up with a decision, by the way, I'm not looking for, okay, let me first say, for example, you get health insurance information, okay, or some of the financial information, if that's into the consideration. But I do want, when I say innovation about the first question, I really want you to think about how to do it in a way that's actually very ethical. And it's not going to discriminate people with different disadvantage to the so it's tricky. I want you to think about that.
For the first question, we're trying to come up with a scenario to set which vehicle we will hit if that's the case. Like, right. And the first question worked. There is no way we could escape it. So we just have which car we hit. And the second question is like, how would, if you had to go back in time, what would you do to avoid being in that case?
Right. Exactly. I mean, before I even ride my bike into that spot, I mean, how do I actually know that I shouldn't go there? If I go there, am I actually locked in? I mean, with a very small probability. But that is the second question I'm trying to do. One is what I call avoidance. The second question is avoidance. The first question is how do you pick and choose once you got locked into that situation. I mean, to be honest, in real world, you're still going to deal with number one, regardless, because no matter how we try to do avoidance, we always will have situations we cannot avoid. So that's the problem that's the government or the academics are challenging the industry about how do you actually define the safety for autonomous vehicle. And we know that autonomous vehicle actually certainly is safer than the current vehicle, which because human error is a lot higher than but still the autonomous vehicle need to deal with this kind of very unlikely but very tricky event. In that case, it's going to involve insurance, it's going to involve liability, and who's going to handle that. That is actually
a question for Simon for homework number one. Talking to the TA, he wasn't aware about. When we talked to him about homework one, said as long as it works, doesn't matter what algorithm or fast or slow. And there were two. You provided on your GitHub repository, there were two files for the portal.
Right.
We could use anyone, doesn't matter.
Yeah.
The one you modified or the one from the original.
Right.
The TA was not aware. It was like, oh, he didn't know whether or not he should grade it based on how fast and how efficient the algorithm is, or whether or not just you just get the right output.
I will talk to the TA about that. TA probably missed some of my lecture. During the lecture, I think I made it clear. That's not the performance is not an issue.
And using the original file
is either way is okay. Yeah. Yeah. TA probably missed that part. I mean, because
for the script, I'm using LLDP for M1. All I have to do is while I'm writing the code, I know how to debug,
Right.
I know how to set breakpoint, I know how to
Right.
look at the stack and
You just use LDB or GDB to run the program once.
and about the script file that I generate. It just needs to show like, oh, I know how, like I set breakpoints.
Right.
I went through, I saw the values, I looked at the stack and
Yes.
the range.
Right, right. So you use a script to actually be able to capture them. Yeah. Okay. Okay. Any other question? Yes, please.
So regarding, be allowed to use the solutions.txt or do we have to use all?
What's the difference?
All that txt is like all the words that the program can recognize that the program that you wrote.
Right.
And then solutions.txt is the
Oh, I see. I see.
words that can actually be.
In the puzzle, right? I mean, it's fine. I mean, if I were you, no restriction, I probably use solution, not TXT, right? Because it's the candidate is a little bit small. Yeah, it's okay. Using either solution TXT or ALL.txt is fine. The only thing you cannot use is that you directly look at the solution, the word, that array, and then use that as an indication to filter it or other things. That's actually illegal. Other than that, everything you can do anything you want.
What array?
There is an array called word. Word is a 5-character array. That's actually when you the actual you should use that one. Other than that, you can use anything you want. Yeah. And just clarify, I'm not worried about how fast your program does. I don't worry about if you guess 1 million times and then finally got to the answer. But I care is your program, it's a C program, you can actually eventually guess it. So it's okay for you to just iterate through every single one in the solution.txt and see if you can match. That's actually fine with me. That's okay. That's a strategy, by the way. It's a strategy.
And
What?
If our program is perfect, like we're able to get the answer most of the time, and once every blue moon, it's just segmentation fault.
I think if the TA will not catch that, they will give you full credit. But if they catch that, they might give you some credit. You cannot do.
what?
No, for example, your program works for 99%, and then 1% doesn't work, and it's hard for the this is called software testing is actually pretty hard, right? How do I actually test? I mean, unless the TA is willing to have a way to test every single solution, then my guess is the TA will only test for maybe 3 to 5. If it works, he will let it pass. Okay. All right. Any other questions about midterm or homework 1 or homework 2? By the way, this is similar to homework 2. So homework 2 is something called record. And the record is essentially, you can think about record is a one interaction. If you think about that, a record is a one interaction when whenever I have this interaction, I keep it as a record. Because, I mean, have you heard about something called black box for the airplane? So the airplane will always record all the record in the black box. If there is any kind of crashes, they will actually analyze. I mean, similar here, this is like a record because the government is actually going to look at this and say, well, how can this traffic accident happen this way? I need to see how the record about how the autonomous vehicle talking to a motorcycle, and then decide, whether whose fault it is. Is it algorithm's fault or the human's fault or some of the design's fault or things like that? And that's actually very important for us for the society to actually build our trust in technology. I mean, the midterm exam, you might find it a little bit untraditional. Untraditional means that usually we don't you don't got to ask this kind of way to answer the question. But this is actually the question that really provides transparency about our technology and how should we trust a technology like autonomous drive without some equivalent information like this. But the other thing I do want to tell you is that I try to give you the chance to try the object-oriented programming or modeling the real power. The real power is not just about writing a correct program. The real power of object-oriented programming is that you have a really complicated scenario, which we don't know how to solve. We don't actually know what's the possible innovation we can build there. But you don't need to build an autonomous motorcycle. You don't need to build a robot, but you can actually build objects very easily and try to explore the interaction and try to explore how some of the innovative idea might be able to realize for our society. And the thing is that usually we actually think about this kind of issue until we build the box. But this is actually a way we start. I actually sometimes call the object-oriented programming the innovation language, because it allows us to be able to pre-test a lot of idea in a simulation way. And then for us to actually be able to evaluate a lot deeper than just without the programming, because then we don't know how machine might be able to communicate to solve this problem. Okay, so that's the purpose I want you to emphasize. And just let you know, after you're done with this, then after midterm, I'm going to switch the final project mode. So you can think about what is the final project? Final project is for you to pick a very challenging problem, a very innovation problem, and then using the same way to design. You have the class hierarchy, you have the containment hierarchy, and you have the interaction. The only difference between the final project and the midterm is in the final project, you actually really write the program in C++. And you can demonstrate. You can actually realize the scenario to the end. So that is something just give you a heads up about what's going on in the final project. Okay. Okay. Wow. It's I'm actually moving faster than I thought. So I still have about 7 minutes. So any question? Yes, please.
So I'm just curious, like, how are you gonna, like you said, you want like innovation and how ethically we can do this, but how are you gonna grade innovation and how like and ethics? Like is there a rubric or like what are you expecting?
Oh, okay. It's
still subject
to me, right? But let me give you some example. Okay. When I say innovation, is usually something which is pretty surprise. Somewhat surprised. I would say pretty surprised. Somewhat surprised. For example, I just give an example. You actually leveraging some of the psychology information. I mean, we're talking about innovation. Innovation really depending on what information is being communicated and how it's based on that information. So I mentioned the information could be psychological, could be physical, could be health, could be financial, right? So the thing is that I think the innovation comes from what information you would like to pick, or you can actually design some kind of robot to remember I have that robot. So you can actually add whatever component you want to have and be wild as much as you want to, and then you can communicate to whatever the new capability you actually implement in either of these devices. So for example, just example, if I actually include the information about the psychology, that this person's mental state and things like that, at that time, I have a clever way of utilizing that information to make a decision And that decision, by the way, is not, I mean, the basic rule I'm actually looking at, I would say, whether this will have discrimination or whether this is actually going to be sometimes unfair to, so if you can actually think about some information passing to reduce the damage, to maximize the survival rate, and yes, to avoid some of the well-known discrimination situation, I think that would be both sides. On one hand, you want to use more information. I'm not giving you a very clear answer, right? Because it's hard. It's a surprise. Yes, I'm back. Okay. The difference between let me go back so my computer can hear my voice. That's an excellent question. Thank you. So unfairness, in my mind, is picking a feature about which one to hit, not relevant to saving others' life or try to protect life. So what is unfairness? What is discrimination? Or what is unfairness and discrimination is that we did not try any human being the same as others. That's the definition. So therefore, unfairness is that we should definitely avoid using those features. On the other hand, that we do need to sometimes make a decision. For example, one person is really healthy and the other person is really unhealthy. Well, I shouldn't say healthy. I should say one person have more likely to recover and what.
What if the person say one is healthy, but the other one is just had the other person has unhealthy choices in life where they wouldn't take care of themselves, but there's a person who's not healthy because they have cancer or but they were born sick. They're not healthy, but it's not their
Right. Okay, so that is interesting because then it's an innovative idea because you actually dive into the not just healthy, unhealthy, but you actually dive into a more fine-grained information for you to pass or understand. So even that is actually tricky. I mean, just give an example using your example. One person is actually just have some kind of unhealthy habit, and the other person actually has cancer. And in this case, we as a human being need to make a decision that whether that should be a relevant decision for us to make. Whether we think to hit which side was higher. It's just like whether we want to hit the person that's responsible for wearing helmet or not.
What about this case? Say we exchange information with both people. We get the information and we do our own calculation to weigh out the risk, and we come to a conclusion where both people people on each vehicle have the same contribution to life and they're healthy, but no matter whatever vehicle we hit, people on that vehicle will die regardless. So do we just leave it up to randomness at that case? Because there is no.
Well, at the end, it has to be randomness. At the end, it has to be random. So that's why actually, let me actually tell you this. In my mind, I feel to use health is not necessarily a good idea because we always easily fall into this kind of trap. So use health information has been mentioned in the literature, but in my mind, use health is actually not going to be too reliable. In other words, I'm actually more worried. I mean, if I were you, I would be looking at the capability of the motorcycle.
Yeah.
I like to look at the motorcycle capability because all this discussion about health is assuming your motorcycle is today's motorcycle you can buy from Davis downtown. It doesn't have the feature. So the thing is that we think that in the future that they should have some feature. Yeah, okay. Yes.
Can you assume that every vehicle is an autonomous vehicle? Or
yeah, we are assuming every vehicle is an autonomous vehicle in this game. Yeah.
And whichever we pick will definitely got 100%.
Well, not necessarily, right? If I have some kind of capability or robot, then I'm actually going to reduce the damage. But you will have my consent. My robot say, under this situation, I know I'm going to get a few scratches, but I'm willing. Just hit me. So that has a decision. So there is a consent to that autonomous vehicle. Yeah. So we're assuming, okay, Kevin, get back to your question. So assuming the autonomous vehicle means they can communicate. So they might have a different capability in terms of protecting their passenger. Yeah.
Great. So in the end, we have to hit somebody. I mean, like living in this line, like if we have some sort of algorithm to measure whether we should hit someone on the right or on the left. So does this algorithm have to include this person in your car? If you think that this person is actually the one who's supposed to be hit, like by any means, by any algorithm, however you judge it, is there an option to just stay in this line?
Yes, that is certainly an option. Even in the original dilemma, that's actually that is one thing that's actually yeah. And to be honest with you, I think it makes sense. Sometimes you realize that's actually an option. You might need to sacrifice yourself. But the thing is that it needs to be transparent. The logic needs to be spelled out in the car. So when you actually bought the car, you better actually analyze this diagram. That's actually what you're getting.
Is the car gonna kill me?
Right. I mean that is just like a program analysis. So instead of talking about safety analysis, we turn it into program analysis to actually see what the program will do under the extreme case. Yeah. And you agree to that, essentially. Yes, in the back.
It is. I mean, this is the solution.
Well, I think that is not necessarily discrimination. If how do I say that? There are two parts. Of course, we want to do our best to try to do that. But when we actually have all kinds of options, the first question, let me go back to the question before what I just said. So we still have to make a decision. But whether that decision is made based on some discrimination concept is going to be recorded over here. And we actually need to analyze. I think it is important for the society. There are some obvious one. We can actually say it's discrimination. But there are certain cases where we actually have to pick and choose. Then essentially the society need to actually be transparent to that process, especially those people who actually fall into that category. And we actually have to say whether that is something which the society is going to be. By the way, you're absolutely right. that in our modern society, no matter how hard we try, there's always case about discrimination. I guess my view is that it's probably okay to have some discrimination, but we need to be transparent about that. We need to recognize that. We need to actually open up to let people take. That's the element of the contract. Otherwise, I mean, today people are like saying that it's good and we're perfect. No. I hope that addressed some of your concerns. Yeah. Okay, let me